Okay, so it is being recorded right now. Okay, the first question, we are just going to prove that a function composition is a bijection. To be honest, the bijection that we have here, it's just a normal function. Like you could totally get this question as a non-composition question. Like when you make the function composition, you're getting a pretty simple function as a result. And the reason I have that is just so you get more familiar with the bijection proof before like complicating it with a complicated composition function. Can anyone tell me what the so I have my composition f of g. Can someone tell me what the domain of my function will be? Any ideas? You all should have seen this in lecture already, like composition of functions. So what will be, so we have f from 0 to infinity to 1 to infinity, and g goes from 0 infinity to 0. Awesome. So it is 0 to infinity. So can someone tell me what the codomain will be? So the domain is this. What's the codomain? Awesome. It's 1 to infinity. And how do I find that? So I think not all of you, some of you will be interested in CS, even if you're not. Like just think of it kind of like an input output machine. So you have f of g. What happens is you have g here, then you have f. So you're given an input. First, the function g happens. So g takes in an input, spits something out, and then f does something to it and spits something out. Okay, this is my output. So your input first goes to g, then g does something to it, gives it to f does something to it, gives it back out. This entire process where I get given an input and get out an output, that whole thing is f of g. So you first do G to an input and then you do F to it. That's why your domain will be the same as the domain of G, because G is the first thing that takes in the input. So the domain of G is the domain of your composition, and the output comes from F. So the codomain of this will be the codomain of the outer function, which is F. Okay, awesome. Now, can someone tell me what f of g of x is? So I already told you. So you basically do g of x first and then you do f of x on that. Okay, so what is f of x? F of x is 1 plus 2x. Okay, so you should do 1 plus 2 times g of x. I realized I just said, can someone tell me? And I just gave out the answer. It's fine. As I said, I had a long day. Um, does anyone have a doubt on how I got the domain, codomain, and the formula of the function? So anytime you see a function, the most important three things about the function, which like basically how to know what the function is, like do you like figuring out if it's injective, surjective, what's the behavior of the function, what's the graph of the function, all these factors. To know that, you need to know three things: domain, codomain, like formula. Formula means what exactly does the function do to an input. That's the formula. It could be just a description, it could be a formula, but it's basically if I give you an input, what does the function do to the input? That's what I wrote here. Then I have the domain, I have the codomain. Any doubts in how I got any of those? Okay, awesome. So all good. So let's go and see prove that it is a bijection. So another thing I want to mention is something we see when we grade all the time is if we ask you to prove something is a bijection, we are not going to give you a function which is not a bijection and ask you to prove it's a bijection. Like if I say prove it's a bijection, you have to prove it. And it might seem silly now, but unfortunately that is a common mistake. A lot of people will see a question, prove it's a bijection, and the conclusion is this function is not a bijection. So that doesn't happen in this course. If we say prove it, we are asking you to prove it, not like is it true or false. Okay, just an aside. Okay, so let's actually prove it. So anytime you see a bijection proof, you have to show two things. One, you have to show it's an injection. Two, you have to show that it's a surjection. Okay, and so you all did your quiz already on bijection, injection, surjection, right? What was your quiz? I completely forgot what your quiz was on. But can someone tell me what an injection function is? Like, what does that mean? If I say a function is an injection, what does that mean? Okay, I don't know how Lean usually does things. I want my students to respond. I will sit here, awkward silences, as long as it needs until you guys respond. Okay, X is unique. Awesome. Every output has a unique input. Awesome. So that means if I have two different inputs, that should give me two different outputs. Okay, it's brilliant. Everything you guys are saying, awesome. So if I have for any two inputs, so if I say for x1 and x2 in the domain, so what's the domain here? It's 0 to infinity. So for any two things in the domain, if the inputs I chose are different, then the output should also be different. That's what it means to be an injection. Okay, so that's like the definition of an injection. But to prove this, so see how this is a P implies Q statement. So this is P implies Q, and P implies Q direct proof. It works sometimes. Some people still do an injection proof with direct proof. It works at times. But in general, the strategy we use is a contrapositive proof. So whenever you see an injection proof, you probably are going to do a contrapositive proof. So hopefully you guys remember what contrapositive proof was. It's not Q implies not P. So that means you're going to say, assume f of x1 equals f of x2, and you want to conclude that x1 equals x2. So that's the proof by contrapositive. This is why we do a proof like that for injection. Okay. Now, that being said, there's another way to do an injection proof. So this is the most common method to show something it's an injection. Like it might be a bit long, but it's mostly it's gonna work. Another alternative, which is not a lot of people do that method, but in some questions that might be easier. I'm trying to find out which definition it is. Let me see. It's somewhere there in your course notes. Injection, surjection. Give me 1 second. There's a number for this definition. Oh, okay. So if you look at your course notes, so I'm going to write the alternative in green color so you don't get confused. You can look at definition 5.1.3, and you can look at proposition 5.1.4. Definition 5.1.3 is just a definition for a strictly monotone function. So if you're doing calculus, you are very familiar with this. It basically means a function which is always strictly increasing, i.e. it's like as the input is going, x value keeps increasing, the y value also keeps increasing, or it's strictly decreasing. That's basically what the definition 5.1.3 is. And proposition 5.1.4 tells you that if a function is strictly monotone, um, and like basically if you have a function from a set to the real numbers and it's a strictly monotone function, then it is an injective function. So you can use this logic. So if you want to show something it's an injection, instead of doing this contrapositive proof, which I'm going to show in a second, the other alternative you could do is you can show that this is a strictly monotone function, and then you can say, since it's strictly monotone, by proposition 5.1.4, um, you can say that this is an injective function. Okay, but note that that works. There is a condition given in your proposition. So in this case, I'm not using it because in your proposition, it said that this works when you have a function going from a to the reals, where a is a subset of the real numbers. And here, technically, a codomain is not the real number, so it might not be the best choice here. But in general, if you have a question where you know the function is going from a subset of the reals to the reals, you could also use this method for an injection proof. Another only thing you have to be careful about. So first thing careful is what's the domain and codomain of the function. Second thing you have to be careful about is when you show that the function is strictly monotone, do not use calculus. Like in calculus, showing something is increasing and decreasing, you learned a lot of methods. Don't use those. If you want to show something is strictly monotone in 102, you have to show that the function satisfies this definition. You're not allowed to use calc methods. Okay. So that's a long aside, but just so you guys know. Coming back to this question, let's do the contrapositive proof. So we are assuming the two outputs are same. So that tells me 1 plus 2 cube root of x1 equals 1 plus 2. So this is just simple algebra. Hopefully you guys, it shouldn't be too bad. I'm just subtracting 1 from both sides. I'm canceling 2 both sides. So I get cube root of x1. This is just me writing out every single step. And then you can like basically cube both sides and you get this. Okay, once you have the structure, the algebra is not at all difficult in this question. In reality, the quiz questions, algebra will be slightly more challenging. But once you know the structure and once you know what you're trying to do, that's half of the marks already that you have gotten. Okay. Always like once we know, like you kind of know what you're trying to do, you get a lot of partial marks. The algebra is not the be it ended. So even if you don't know the algebra in a particular question, if you know this is what I'm trying to prove, you still get a lot of mark. Okay. Any doubts? So can we move to surjection? As I said, if I don't hear any feedback through the chat or mic, then I'm gonna wait. Okay, awesome. Let's do surjection. Okay, so surjection, to put it in simple words, surjection tells me the codomain is equal to the image. That's the simplest way to say what a surjection function is. If a function is a surjection, its codomain is equal to its image. But by definition, hopefully you all still remember this. I don't know when you learned it. You learned it at some point in your life and in 102. By definition, image is always a subset of the codomain. Okay, like codomain, that's the definition of a codomain. It's everything in your image plus it could have other things. So image is a subset of codomain is always true. Okay. Okay, by the way, notice the codomain is a set, image is a set. I want to show two sets are equal. How do you show two sets are equal? You show they are subset of each other. So this was something you learned in sets. So if you technically, if you want to show the codomain is equal to the image, you want to show that image is a subset of codomain and codomain is a subset of the image. But as I said, the first part of it, which is image is a subset of the codomain, that's always true by definition. So you don't have to prove that. So the only thing you are left to prove is that the codomain is a subset of the image, which is why surjection proof is the structure works the way it does. So here, what that means is you want to show what's the codomain here? 1 to infinity. You want to show 1 to infinity. I'm probably going to use a different color so that you don't get confused. You want to show 1 to infinity is a subset. Also, you guys are so used to seeing Ling's like writing and her voice. She has the sweetest voice on earth and she has the best like handwriting and neatness in the world. So I apologize for this messiness after being used to her perfection handwriting. Okay, so you want to show that the codomain is a subset of the image, which is, this is the notation for the image. Okay. And how do you show a set is a subset of another set? You take any element from here, you have to show that it's in here. So you pick any y in 1 to infinity. You want to conclude that y is in f of g. I'm not going to read it aloud. It's just the notation for the image. Okay. So if I want to say y is in this image, the image is basically the set of all outputs. Okay, so image set of all outputs. So I'm saying y is an element in the set of all outputs. So if y is an element in the set of all outputs, that means y is an output. Okay, so this basically tells me I want to show the y is an output for some input x in the domain. Okay, so this is what I'm trying to prove. I just need to fill in the space in between. So this is a structure for a surjection proof. You start by saying pick any y in the codomain. Your last statement should be y equals f of g of x for some x in the domain. Hence y is in the image of the function. Okay, so our goal here is to find this x. When we do a surjection proof, our goal is to find this x. What x will satisfy this property? Okay. So I'm going to do some rough work. to find that. So I want y equals f of g of x. So remember, I'm writing this as rough work. I can't start here. I can't write here to here directly because this is what I'm trying to prove, that y equals f of g of x. Okay, I don't know that. I'm trying to prove that. So I'm trying to find, can I get an x where this is true? So let's see. If y equals that, then y is also, how to find the x, it really depends on the question. So do more practice, you'll get better at it. Sometimes it's just easy rough work like this question here. This question is relatively easy rough work. Sometimes you really have to like break it down into cases and you have to like think, especially when you go from like sets like n cross n to n, something like that. You go from two variables to one variable. Such questions, you really have to give it a lot of thought. So do practice, practice, practice on coming up with your own strategies on how to find this x. Okay, so y minus 1 by 2 equals cube root of x. So that tells me x equals y minus 1 by 2 cube. Now, I want you guys to pause here a second. A very common mistake is once they get a formula for x, people are like, I'm done. I have a formula for x. That's the x I wanted. But be very careful of what I wrote down here. Not only did I say that x exists, the x has to be an element in the domain. So you always, once you get an x value, check that this is an element in the domain. And here our domain is 0 to infinity. So you basically want to see, is my x in 0 to infinity? And a quick tip that I'll tell you, obviously this is a bijection, so it will magically work out. It will magically be in the domain. And the reason it will be in the domain is because you chose y in the codomain. Okay. And why does it match up perfectly? Because we are giving you a function which is a bijection. That's why it basically works up very well. Okay. And you can see that here. So we know y is bigger than or equal to 1. So that means y minus 1 is bigger than or equal to 0. So this is a positive number. 2 is also a positive number. So you have a fraction with two positive numbers. So the entire fraction is a positive number. And the cube of a positive number is also positive. So since y is bigger than or equal to 1, you can conclude that x will be a positive number, which is basically our domain. Okay? So this is rough work. So my actual answer I'm going to write in blue. So pick any y in 1 to infinity. Let x be equal. Actually, I'll write it here. Let x be equal to y minus 1 by 2. So the green thing you don't really have to write in your solution. It's just how you figured out this is true. Now again, we have to check x is in the domain. So you will have to write that since y is bigger than or equal to 1. This means y minus 1 bigger than or equal to 0. So y minus 1 by 2 is bigger than or equal to 0. So x is bigger than or equal to 0. Okay, so this part is very important, something people miss a lot, confirming that our x is in the domain. So basically, if you want, you can plug it and see. So the next step is, if you want to see, you can, if you want to convince yourself here, f of g of x will be f of g of y minus 1 by 2 the whole cube. And you can plug it into this function and see. So if you plug it in, again, what I'm writing in green now, green you don't need, but it's just to convince you. Like if you plug this in as your x, when you solve for this, you're going to end up with y, which is what we wanted. Okay, so you can just like say blah 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 blah, and you have to end up with y. You will get y because we chose our x like kind of working backwards. So we chose x such that we know we are going to get y when we solve this. Any doubts? Again, I apologize for the messy board. Any doubts? Are we good? Okay, awesome. So if you have doubts, you can go to Ling's office hours. You can come to my office hours. When is my office hours? I should know this. Oh, my office hours are Wednesdays 5 to 5:30. So basically around this time, but on Wednesdays. So if you have doubts, you can ask me or Ling, your preference. Only thing I want to mention, something else. So this is the entire bijection proof. So you need injection, surjection. Follow the structure, do lots of practice. Surjection is usually slightly harder because coming up with the X requires a lot of thinking. And this question was straightforward. Something you should be careful of is a lot of people think if I can find an inverse for the function, then that shows it's a bijection. This is wrong. In 102, only thing you learn is if it is a bijection, you can find an inverse, not the other way around. So the second, if I show you a question like this and you find an inverse for it, second you find an inverse, you're telling me it is a bijection. Because in 102, you know an inverse exists only if the function is a bijection. So finding an inverse to prove it's a bijection makes no sense because it works the other way around, the implication. So be careful. That's not a proof. I'm going to clear the board in 5, 4, 3, 2, 1. So if you want to take a screenshot, please do, because I have to clear the board. Okay, awesome. Let's see what the next question is. Okay, so this is a question I'm probably not going to do everything in class. Let's just do question 1. As I said, some of these questions, they test the same logic, but it's just a different question. So I might just do one question and explain it a lot and post the solutions to the other ones. So let's just do question 1 for this. So you have a function f going from a to b. Your a is this, your b is that. And you have a function g going from b to a. The question is also, I don't know how to spell. This should have said such that. Nobody in my previous tutorial noticed that. Good to know. So can you find a function going from a to b and another function going from g to a, f? Okay, let's restart that statement. I can't speak. Can you find a function f going from a to b and a function g going from b to a such that f of g equals g of f for every input? So basically, no matter which input I give in, I get the same, like for the same input, I should get the same output for both f of g and g of f. So you have two machines, one is f of g, another is g of f. They do the same thing to all inputs. They basically, they function, their formula, if you can think of it like that, will be the same. Ouch. Can you find a function like that? If yes, which one? If no, why not? Okay, awesome. So we have an idea. Let G be F inverse. So you want to say F1 of F1 inverse of X equals F1 inverse of F of X. So I want you to be, can you tell me, so let's plug in the value, I can't speak today, guys. Let's plug in a value for this, okay? What value can my X take? If this is true, literally just tell me what value, what input will you give in? Just tell me one input you're going to give in to the function. One value you're going to give as an input. Okay, so so 0, remember what the domain and the codomain is. This is why I mentioned in the beginning, when you have a function, every time, and as 102 students, when I was in 102, especially when you're new to uh, university math, every time, you kind of think of a function as a formula. Like you never think of the domain and codomain as being very relevant. We know that, and we want you to think different. So during tests, we will test you to see, are you being careful of the domain and the codomain? Okay, so be very careful. So everything you guys are saying makes sense. Like f1 is x plus 3 f2, so it makes sense formula wise. Just looking at it, you're like, yeah, it kind of makes sense. It goes there, it comes back. It's an inverse function. So I'm pretty sure you guys have all learned this f1, f inverse, and f inverse. Like f, they all give the identity. Like you should get, if you give in x into here, this gives out x as an output. Same here. You give in x, you get x as an output, which is why it's the inverse. That's a definition of the inverse. Both of this will give me, if you give an input x, you should get the same output x back. But be very careful. Are these functions equal to each other is a whole different other question. They might be doing the same thing in the sense they take x and give you back x. But what is the x that they are allowed to take? That is different. So if you look at the left-hand side here, remember, if I write it like that, this basically means I'm doing F1 on F inverse x. So I first do F inverse x and then I do F1. So my input should be in the domain of F inverse. So the kind of numbers that can go in, look at the domain and the codomain of the function. So this is A, this is B. I can do F1 of F inverse. So we are calling G1 as F inverse, right? So let me just write that. F inverse. So G1 goes from B. So I can do it on 4. I can do it on 5. I can do it on 6. Let's say I try to do it on 1, 2, or 3. Like 0 is not in the domain, so you can't attempt 0. If I try to do it on 1, so how do you find out the answer? You first have to do what is this? But F1 inverse, we called G1 as that. F1 inverse is only defined from 4, 5, 6 to 1, 2, 3. You cannot give in 1, 2, or 3, 0, nothing like that can go as an input because it's outside the domain of the function. So the only inputs you can give into this function are 4, 5, and 6, which is its domain. On the other hand, if you look at the right-hand side, this is, you do F1 first and then the inverse. So the inputs you can give in here are 1, 2, and 3. So you can do this on 1, 2, 3. These are the inputs that can go into this function because F1 goes from 1, 2, 3 to 4, 5, 6. But you are right in the sense, since I'm talking about inverse, this gives me 4, this gives me 5, this gives me 6. So if you give an input, I get the same number back as an output. Here, if I give in 1, here I'll get 1 back as output. If I give in 2, I'll get 2 back as output. 3, I'll get 3 back as output. So the formula, in the sense what the machine does, is the same. You give in x, I get back x. But which x am I allowed to give in is different because the domain of the function is different. And that's why it's actually not possible in this case to find a function. And so this was just talking about inverse, but if you see in general, the left-hand side, G1 is the inner function. So the domain depends on G. So the domain of this is B. This function has domain B. Here, the inner function is F. So you have to do F first. So the domain is A for this function. So they both might do the similar thing, but they work on different numbers. They have very different inputs going in. So overall, the function are not the same. When you say two functions are the same, they should have the domain same, codomain same, and the formula or what they do the same should be the same. In the example we just did, the inverse, the only thing that's same is the formula. The domain and codomain are different. So you can't say the functions are equal. To be equal, all three have to be equal. Does that make sense? Also, this took way longer in this class than it took in my tutorial. I have no idea why. Does it make sense? Like why it's impossible? Again, it's impossible because they have two different domains. So they work on two very different things. One of them works on one set and another one works on another set. So you can't say they are equal. So this is why I'm going to reiterate, and it might seem repetitive. You see a function, don't simply think of the formula or what it does. Domain and codomain are equally important, especially like injective, surjective. So going on aside for a second, 102 loves giving questions like, for example, if I said, why can't I write? F of x equals x squared. Again, I simply asked you, is this injective or not? 99% of students say, no, it's not injective because negative, positive, they give the same square back. But remember, you really can't say whether a function is injective or surjective or whatever unless you know the domain. So this function, if it's from R to R, this is not injective, okay? Let's put a cross like that. But if I set the same function and I change the domain to like 0 to infinity, this suddenly becomes an injective function. But so far, everyone thinks x squared not injective, not injective. But that's exactly why they love asking you questions like the second one. They'll ask you a very common formula, but a different domain or a different codomain, and then you'll like get confused. So always, always, always look at domain and codomain and the formula. All three are equally important. When you want to decide if something is injective or not, you have to look at the formula or what the function does and at the domain. Okay, that's true for injective. If you want to know if a function is surjective or not, remember, surjective was codomain equals image. So obviously, being surjective or not will depend on the codomain. So when deciding whether a function is surjective or not, look at the codomain and at the formula or what the function does. Okay, so again, injective, look at domain and formula. Surjective, look at codomain and formula before making a decision. Any doubts? That was a bit of an aside, but I think that's important to mention. Again, I apologize for the mess. I'm going to clear the board in 5, 4, 3, 2, 1. Okay, so let's just, so that is x plus 3 and x minus 3. Let's just take that as an example for a second. If f equals that and g equals this, let's just do that for a second. So what is f of g of, tell me one value you can find. Okay, let's look at what is f of g of 1 and what is g of f of 1. What's f of g of 1? Come on, you guys are the ones who asked me. Awesome. So be very careful. It can't be 1. And this is why, so thank you for asking the question. The fact that you guys think it's 1 makes me realize that my explanation was not clear enough. So I want to make it very clear. It's not 1 and 1. And the reason is, so maybe if I draw a picture here, it will make more sense. So you have the set 1, 2, 3. Okay. And you have the set 4, 5, 6. Okay. G, no, F goes from this to this. G goes from this to this. Okay. So there is no such thing as G of 1. G of 1 does not exist. You can't say G of 1 equals negative 2. That's not, because like G is x minus 3. So G of 1 equals 1 minus 3 is negative 2. That does not make sense. G is only defined for G of 4. This is the only thing you know. G of 4 is 1. G of 5 is 2, G of 6 equals 3. Okay, so you can find G only on 4, 5, and 6. That's why this was given. The domain is B. Okay, so when I say f of G of 1, this basically means f of G of 1. So you first have to find G of 1 and you do whatever you output, you get f of that. But G of 1 does not exist. So you can't really find it because G of 1 is outside the domain of this function. Okay, here you can find, because f of 1 is defined. F goes from this to this. So f of 1 is just 4. So you get G of 4. And then you know what G of 4 is. This is 1. So that makes sense, but not on the other side. Similarly, if you try to find f of G of 4, that makes sense because that is f of G of 4. G of 4 is 1. So you'll get f of 1. F of 1 is 4. That makes sense. But if you try it the other way around, which is G of f of 4, you'll get G of f of 4. But if you look, f goes from 1 to 3. Like f of 4 doesn't make any sense because f can only take in 1, 2, and 3 as the input. So this does not exist. So you can't make any sense. So yes, the functions do the same thing in the sense they kind of cancel each other out and you get input equals output, but the inputs you're allowed to give in are different. Okay. For f of g, for this function, you're allowed to give in 4, 5, and 6 as your inputs. For this function, you're allowed to give in 1, 2, and 3 as your inputs. That's why they're different functions. The only similarity is that they give input equals output, but the input itself are different numbers. Does that make sense? Any doubts? Guys, come on. Awesome. Okay. So if you still have doubts, office hours. Okay, I'm going to clear the board. Okay, so I'm going to show a quick video. This took way longer. Hopefully it's gives some motivation. Hopefully it's not too bad and too long. Oh, if only I can find the video. Okay. Can you guys hear this?
In the 1920s, the German mathematician David Hilbert devised a famous thought experiment to show us just how hard it is to wrap our minds around the concept of infinity. Imagine a hotel with an infinite number of rooms and a very hard-working night manager. One night, the infinite hotel is completely full, totally booked up with an infinite number of guests. A man walks into the hotel and asks for a room. Rather than turn him down, the night manager decides to make room for him. How? Easy. He asks the guest in room number 1 to move to room 2, the guest in room 2 to move to room 3, and so on. Every guest moves from room number n to room number n plus 1. Since there are an infinite number of rooms, there is a new room for each existing guest. This leaves room 1 open for the new customer. The process can be repeated for any finite number of new guests. If, say, a tour bus unloads 40 new people looking for rooms, then every existing guest just moves from room number n to room number n plus 40, thus opening up the first 40 rooms. But now, an infinitely large bus with a countably infinite number of passengers pulls up to rent rooms. Countably infinite is the key. Now, the infinite bus of infinite passengers perplexes the night manager at first, but he realizes there's a way to place each new person. He asks the guest in room 1 to move to room 2. He then asks the guest in room 2 to move to room 4, the guest in room 3 to move to room 6, and so on. Each current guest moves from room number n to room number 2n, filling up only the infinite even-numbered rooms. By doing this, he has now emptied all of the infinitely many odd-numbered rooms, which are then taken by the people filing off the infinite bus. Everyone's happy, and the hotel's business is booming more than ever. Well,
again, that was a bit of it was not an aside. It was to give you guys some motivation on infinite sets. Okay, so basically, infinity is a concept that makes a lot of people confused. If you want to watch the rest of the video, I highly recommend it. I absolutely love the video. The first time I saw that, it was before I was in 102, and it was like blow my mind. So it's just to tell you like what infinity is different from what we think. It's not like all infinity is not the same. Infinity is not a number. You can't say infinity is bigger than infinity, infinity equals infinity. Nothing like that makes any sense. And this is important when you start talking about the concept of cardinality. And I wanted to show you an example how. So this question. So when you think of cardinality, so remember the question that the person said about, wait, which example was that? So I'm going to do that first. So let's go back 1 second. So he said how if you have everyone already filled in a hotel room and suddenly another bus comes up with infinite number of passengers, can you fill them? And the answer was yes. Just take the current people, put them into 2 times their current room number, and you suddenly emptied all the odd numbers. And this is very confusing for a lot of people, but this is basically a very common concept in 102, which I'm pretty sure a lot of you already saw in lecture. Like, because I think your lecture on this is already over. So this is how we actually show that the integers and the natural numbers have the same cardinality. When we talk about cardinality, a lot of people think of it as the number of elements in a set. This makes sense when you're talking about finite sets. When you come to infinity, it's not exactly the number of elements, it's slightly more complicated. Because if you simply think natural numbers is just like 1, 2, 3, 4, 5, blah, blah, blah. Integers is 1, 2, 3, everything, plus it has a lot of numbers extra. So it intuitively, a lot of people might think, integers somehow have more elements than the natural numbers, but it doesn't. It turns out they have exactly the same cardinality. So if you start thinking about them as number of elements alone, it's slightly confusing. And how do you show they have the same cardinality? That's basically what this hotel paradox manager did. All you do is you just want to find a bijection. So they have the same cardinality, and this is something we are going to show. Two sets have the same cardinality if you can find a function between them where it's a bijection. So the second you find a bijection between two sets, they have the same cardinality, okay? So all I have to do is find a bijection between the sets. So I have the natural numbers, and all I do is I take the existing people and send them. So I'll send 1 to 1. I'll send 2 to twice of that. So that was a bit more complicated. I'm going to make it slightly more simple. All I'm going to do is I'm going to send them to odd numbers to the natural numbers. Okay, so 9 goes to 5 and so on. So I kind of leave a space empty in between. But since there is infinitely number of elements in there, I know at some point I can send them to each natural number. And the even natural numbers, I'm going to send it to the negative integers. This will go to -2, -3. So I basically made a way of like sending my numbers to the integers. I can do this for every integer. Wait, did I miss a number? 1, 2, 3, 4, 5. No, I didn't. Okay. So basically every integer I can do this for, and nothing will get repeated by the way I wrote it, because every even natural number will go to odd integer, positive integer. So not an odd integer, a positive integer, and every wait, did I send even or odd? Okay, sorry, repeat. Every odd natural number will go to a positive integer, and every even natural number will go to a non-positive integer, which is 0 or the negative. And there's a systematic way in which I sent my elements, which is basically what the hotel manager like did. He found a systematic way to move the room numbers. Okay, and this is my bijection. So you can find this bijection basically becomes f of n equals okay, you basically can find a function. This is going to be n minus 1 by 2, I think. N plus 1 by 2 if n is odd. And it will be n minus 1 by 2 negative. No, n by 2 minus 1 if n is even. I'm pretty sure this is the function. So how I found these things is I was like, 1 has to go to 1, 3 has to go to 2, 5 has to go to 3. Like, can I find a pattern? And I'm pretty sure it's n plus 1 by 2. Yeah, it's n plus 1 by 2. And then I was like, 2 has to go to 0, 4 has to go to -1, 6 has to go to -2, and so on. Can I find a common way to write it down? And I'm pretty sure it's this minus n by 2. So -2, yeah, and -1. Like finding this comes with practice. Like looking at what the map is and figuring out what the actual formula is comes with practice. So I found a function bijection from n to z that tells me this function is a bijection. Okay. Any doubt in that? I'll do one quick more example and then we'll end today's tutorial. One more quick example. Any other quick doubt? Okay, let's do one more question and let's see if you guys find it clear. So I'm going to erase the board now. And hopefully like the next question clarifies it a bit. So let's do another question. So again, you want to show that these two sets have the same cardinality. So as I said, to show two things have the same cardinality, you basically want to find a function from this to this, which is a bijection. Okay. And keep in mind, like if I know there's a function a to b, which is a bijection, okay, then f inverse is a bijection from b to a. So basically, if I tell you to find a bijection between two sets, you could do it either way. You can either go from left to right or right to left. It's up to you. One of them is probably easier. So can someone think of a function from 0 to infinity to -infinity to infinity, or the other way around? Also, this is not supposed to be this. It's supposed to be this. Or the other way around. It's up to you. Can someone think of a bijection between these two sets? It's a very common function which you all probably have seen. Any bijections you know of? A function which takes positive number, but it can give out any real number as an output. Or the other way around, can you think of a function where input can be anything, but no matter which input you give, your output is going to be positive? X squared plus 1 from right-hand side to left-hand side. So let's see. So if you have g from minus infinity to infinity, going from 0 to infinity, and g of x equals x squared plus 1, let's think about squared plus 1. What will g of half be? Is that right? No. You're adding, it's not a bijection. And let me think. Okay, so which number will give you, like, let's say this is 0 to infinity. So 1/2 is in here. And if I want it to be a bijection, there should be some input giving me 1/2 as an output. Okay. So, but wait, can you guys not see what I'm writing? I just realized. Chincha. Let's see. I was writing so many things on the board. Okay, guys, give me a second. Let me try and see why this is working. Not working. Okay. Wow, that just set me back on time. Okay, so basically, okay, I was writing, guys. I'm so sorry. I just realized it now that because in my other screen, I couldn't see anything. Okay, so basically I was saying, let's find f from, okay, now it's going. Okay, so the idea given was f of this from 0 to infinity, and f of x equals x squared plus 1. But the point is, if this is true, this function's image is actually 1 to infinity. And you can think why. Because x squared is bigger than or equal to 0. So x squared plus 1 will be bigger than or equal to 1. So the image and the codomain are not equal. So this is not a bijection. Okay. So I'm going to give you guys the answer for the sake of time. But a common function is e to the x. Okay, so this is the graph. Hopefully you guys remember this. So if you take e to the x, any input you give in the real numbers, your output is always positive. Or in other way, you can think is log x. So log x is a function from 0 infinity to any real number. So your input should always be positive, but your output can be anything. And you can see they are inverses of each other. So this goes from right to left, and the other thing goes from other side, and they're inverses of each other, which is basically what I said. You could have found either one. So knowing high school common graphs will help you, just in case. And the next two questions is, so we said I'm almost done, okay guys, last statement. So if you want to show two things have the same cardinality, find a bijection between them. If you want to show A has a cardinality less than or equal to B, you basically have to show there is an injection from A to B. Okay, so know this is again there in your course notes, you probably saw in the lecture. So question 2 and question 3. In question 2, find an injection this way because this has a smaller cardinality, the right hand side. Question 3, find an injection this way from left to right. And these are actually much easier. Like you just have to, I'm going to leave it as an exercise. It's much easier to find an injection than to find a bijection, which is why I did the bijection one in class. So try to see a pattern and try to come up with an injection. As I said, I'll post the solution, so not to worry. You will know the answer for sure. Okay. Any doubts? Okay. Also, probably because I gave an introduction, I took longer to do this much than I did in my previous class, which is we had one more question, but anything we didn't do, as I said, I'm just going to post it. I think the main concepts I was able to cover. So my main goal was not the questions themselves, but the concepts, common mistakes, letting you know the structure, all those things. Hopefully that was clear. If you have any doubts in that, just you can come to mine or Link's officers, email Piazza, anything of that sort. So the recording will be posted on Link's channel. Any question that I didn't cover, the slide will also be put up in her resources. And any question that I didn't do yet, in class today, I will be posting the solution to that. Is this the only way? The only way to show cardinality right now for you is to find a function. Yes. Like a lot of people think of like, drawing the map like I did from integers to naturals to integers. But when you draw the map, you're indirectly finding the function. So that's technically you're finding a function when you draw the map, like I did for naturals to integers. So yes, you have to find a function. If you're trying to show two things are having the same cardinality, find a function. And the function, it's not always as good as e to the x and log x. Like e to the x, it works perfectly right now. But if you look at your course notes, they're going to have a lot of other methods of finding the function. Okay, it might look very different than, did I find a function? It won't be clear because they might not give you a formula for the function. The explanation might be like draw lines from here to here, draw a diagonal like this, and crazy explanation. But at the end of the day, they are actually finding a bijection. And during a test, be familiar with all the methods. We usually ask questions where it's easy to find a function and not like, some crazy drawing kind of explanation, but like Candace diagonalization argument and all those kind of Candace diagonalizations here, right? Am I tripping right now? No, okay, the rational numbers. Okay, look at the proof for rational numbers are countable. Okay, it's a bit different from what we did. How they find the function, very different from what we did. I think one of the activities in week 10 kind of is similar to that. So it is finding a function, but it looks very different, and it might be confusing to see how it's finding a function. So your course note has a lot of examples like that, where they find a function but very non-traditional functions. So definitely give it a read if you haven't done so already. You want to show the cardinality of a set. So if you want to show cardinality of a set A is less than or equal to cardinality of a set B, all you have to show is there is a function A to B, which is an injection. Okay, so if you want to show two things have the same cardinality, you have to find a bijection between them. If you want to show a set has a smaller or equal to cardinality than another set, find an injection. Here, direction is important. You can't be like B to A injection. Okay, that doesn't work. If set A has a smaller than equal to cardinality than set B, you have to find an injection from A to B. Can someone think of an injection that will work here? So here you have to show this set has a smaller than or equal to cardinality than the naturals. So you want to find a cardinality. Did I just say cardinality? You want to find a function from, okay, I see an answer. Let me just write this down. 5/2, blah, 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 going to the naturals. And this has to be an injection. So James said, I'm going to call it H. H of x is 2x. And that works. That's perfectly fine. It's not a bijection. Remember, it's not a bijection because here h of x, so h of 1/2 is just going to give me 1. H of 3/2 is going to give me 3. H of 5/2 is going to be giving me 5, and so on. So you're technically only getting odd natural numbers as your output. So it's not a bijection, but it is an injection. And so since it's an injection, we're done. Any doubt in this? The last one I'll post. I'm too tired. Any doubts so far? Again, I apologize for the lack of interactivity and energy today. I really am trying so hard to teach right now. Okay, I'm going to erase the board in 5, 4, 3, 2, 1. There's 4 more minutes. Okay, I won't do the actual proof. I will just, can someone translate this? So I won't do the actual proof. I'll post the proof for this, but this says proof using the definition of relative cardinality. This is true. Can someone just tell me what this means? Like, can you translate to the definition? Remember, the definition is if I have this, then I can find a function A to B such that F is an injection. So use that definition that we just talked about and tell me what you're exactly proving in this question. How would you actually go about proving this? Hint, you can use function compositions also. Use function composition. Maybe there is a definition without function composition, but use function composition also and try to see if you can come up with a. I'm going to write one part of it and I want you to tell me what the rest of it will be. So remember, if cardinality of A is less than or equal to cardinality of B, that basically means there is a function f from A to B, which is an injection. Same, if B is less than or equal to C, then there is a function G from B to C, which is an injection. So if so I can translate that to saying there's a function f, A to B, function G from B to C, they're both injections. Then, can someone fill this in for me? I want to basically write cardinality of A is less than or equal to cardinality of C. And I want to use f and g somehow, because only then I can actually prove anything. I can't simply say a new function h, like use a function with both f and g. What is an injection? Awesome, g of f. Okay, so because g of f, remember, g of f is the same as saying g of f of x. So its domain will depend on f. So f takes in a as value. So this whole function will also take in a as values. F sends this from a to b. So g of f will send this from a to b, and then what g goes from b to c. So overall, this will go from a to c. Okay, so another way of saying, like how you would prove the statement that you wrote, you basically all you have to say is if there is a function f from A to B, which is an injection, and there's another function g from B to C that's an injection, you basically have to show g of f from A to C is an injection. Any last minute questions before I wrap up for today? Also, guys, I don't know if you guys know that I always post extra practice activity, but I do. So if you don't try them out, please do. Like these are some harder questions. So if you haven't tried them for the previous weeks, please go back and try everything. Okay, you're welcome. Hopefully this was a helpful class. And next week, Ling will be back. So you'll have nice, you won't have to worry about my messy writing next week. So bye, everybody. Quiz 3 mark is not released. It will be, give us a week. Bye.